Welcome back everyone. This is a continuation to the previous video that we have seen earlier, in which I talked about the introduction of singly linked lists, and I also talked about the traversal of a linked list with an example, and also seeing a function which traverses through a given list. So here, in this lecture video, we are going to see insertion of a singly linked list, in the sense inserting an element into a singly linked list. Singly linked list insertion. Insertion of a singly linked list has three cases. The first one says insert a new node at the beginning of the list, or insert a node at the end of the list. The third one says insert a new node at the middle of the list, somewhere randomly in the list. Middle does not exactly mean the middle of the list, but some random position in between first and last node of the list. Let us consider the first case, inserting a node in singly linked list at the beginning of the list. In this case, a new node is inserted before the current start node. So in this case, only one next pointer needs to be modified, that is new node's next pointer. Let us see an example here. Let us consider this to be the list, and the first node of the list is 15. So we can see here start is pointing to 15, which tells that this is the beginning of the list. And in this case, we want to insert an element, a new node, at the beginning of the list. So to perform this operation, the first thing that we need to do is we have to update the next pointer of new node to the current start node. Let us say the current start node is 15, and we have to first of all create a new node. Now every new node will contain a next pointer which is currently not pointing to anything, so we should make this current pointer point to the current start. Whichever node that is getting pointed by start, we have to start pointing this we have to start pointing the new nodes next to the start of the list. That is the first step. So let us write it as 1. Okay. And the second step is update the start pointer to point to the new node. So once we have made this connection of the next of new node to point to the start of the list, then the second step is to make start point to the new node. In that way, we will be able to insert this new node into the list at the beginning of the linked list. Now we are going to see all these steps and try to convert the steps into program code. So the first step is to create a new node. So this is the step. We have created a variable called new node of type list node, and we are allocating a memory to that new node, using a function called malloc, memory allocation function, where we are passing the size of the list node. So whatever is the one particular list node's size, that size we are passing into memory allocation function and converting it into list node. And basically this whole step provides us a memory that can be pointed by this new node pointer, which is of type list node, as we can see here. So this whole thing creates us some memory which can be pointed as new node, where we can store some data and which will contain a next pointer, and so we can use this node to insert it into our list. The next step that is we have already seen in the previous slide is we have to make the next of new node to point to the current start of the list. So we are saying next of new node. This is a general representation of C language to represent the pointer uh, to represent particular data of a particular pointer structure using this arrow operator. So we are saying next variable that is available in new node to start pointing to start variable, which is currently pointing to the first node of the list. That was the first step. And the second step is we have to make start the current pointer, which is currently pointing to the first node of the list, to make pointing to our new node. So we are saying start is equal to new node, where the new node's address will be assigned to start. So basically start will start pointing to our new node. So this is our second step. Let us put the code that we have seen in the previous slide into a function such that this particular function uh, is taking an integer value that becomes the data of the node to be inserted, and we execute this function whenever it is called to insert a particular node at the beginning of a list. So as you can see, I'm calling this function with a very straightforward name. I'm saying insert at underscore beginning, basically insert at beginning with a value. So this value will become the data of the node that I want to insert into the list. And as you can see, this is the step that you have seen. This is the first step that you have seen in the previous slide. Then I am trying to put a value into the data variable available in new node, that we have seen in the previous video, that every node structure contains two variables. One is a data variable and another one is a next variable, which is a pointer. So this data of new node, I am assigning this value which I am receiving as an input for this function. So whichever value is passed into insert at beginning, that value will get passed to this data variable of new node. And the second step is to make this next of new node start pointing to start, that we have seen in the previous slide. And the third step is to make start point to new node, which will make our insertion at beginning possible. So this ends the video, a short video on insertion of a new node at the beginning of a linked list. Thank you.